Hi guys. So for today our group will discuss about the types of solution for systems of linear equations, which is many solutions. So this discussion was prepared by me and my group, which is Vivigan and Ngawain. So firstly I will discuss about the definition of many solutions. Basically in mathematics we come across equations and expressions. An equation is an expression with an equal sign used in between. An expression is made up of variables and constants terms conjoined together using algebraic operators. An algebraic equation can have one or more solutions. The solution of the equation or the values of variables in the equation must satisfy the equation. In this discussion, we are going to discuss about equations with many solutions and the condition for the many solution with examples. What are many solutions? The number of solutions of an equation depends on the total number of variables contained in it. Thus, the system of the equation has two or more equations containing two or more variables. It can be any combination such as two equations in three variables, six equations in four variables, and so on. Depending on the number of equations and variables, there are three types of solutions to an equation. There are unique solution, or we call as one solution, no solution, and many solution. So today our group will discuss about the many solutions. The term many represents limitless or abundance. It is denoted by the letter infinity.
Now we will look at equations with many solutions. To solve system of an equation in two or three variables, first we need to determine whether the equation is dependent, independent, consistent or inconsistent. If a pair of the linear equations have unique or many solutions, then the system of equation is said to be a consistent pair of linear equations. Thus, suppose we have two equations in two variables as follows. The given equations are consistent and dependent, and have infinitely many solutions if and only if the ratio of A1 to A2 is equals to the ratio of B1 to B2 is equals to ratio of C1 to C2. Next, we will look at condition for many solutions. An equation can have infinitely many solutions when it should satisfy some conditions. The system of an equation has infinitely many solutions when the lines are coincident and they have the same y-intercept. If the two lines have the same y-intercept and the slope, they are actually in the same exact line. This means the system have many solutions. It means that if system of equation has infinite number of solutions, then the system is said to be consistent. As an example, consider the following two lines. These two lines are exactly the same line. If you multiply line 1 by 5, you get the line 2. Otherwise, if you divide the line 2 by 5, you get line 1.
Alright, well, hi guys. I'm Ng Wai Yin, and I'm here to show you examples of how to solve questions that ask how to show that the following system of equations has many solutions, right? So for this example, we're given two equations. The first one being 2x plus 5y equals 10, and the second equation, which is 10x plus 25y equals 50. So how we solve this is firstly let's label it so we can easily identify both equations, and then we compare it with the linear system. The basic formula of linear system usually is ax plus by equals c1, right? Since we have two equations, we just add 1 and 2 for each of those. So since we have these two formulas already, let's just plug in the values. So when we compare it, we get a1 equals to 2, b1 equals to 5, and c1 equals to 10 for the first equation. And for the second equation, we'll get a2 equals to 10, b2 equals to 25, c2 equals to 50. Since we've already identified all these values for the linear system formula, now we can plug them into the different ratios, which is the a1 over a2 equals b1 over b2 equals c1 over c2. So when we plug it in, for the a1 over a2 equals 2 over 10, and when simplified, we get 1 over 5. And for b1 over b2 equals to 5 over 25, which is also equals to 1 over 5 when simplified. And for c2 also, when we plug it in, 10 over 50, which is also 1 over 5 when simplified. Since all three of these ratios have the same value in the end, we can conclude it with the a1 over a2 equals b1 over b2 equals c1 over c2. Therefore, the given system of equation has many solutions. And let me remind you, we can say this because when we look back at the conditions for the equations with many solutions, look, it says here the given equations are consistent and dependent and have infinitely many solutions if and only if a1 over a2 equals b1 over b2 equals c1 over c2. And since we just found it just now, for this, we can conclude that this equation has many solutions because it fulfills the condition, right? Alright, so now let's move on to example 2. Example 2 is almost the same as the example before this, but it has a slight twist to this. So it gives two equations again. So like normal, let's just label it for easy identification, I guess. So but this time we don't compare it with the linear system. This time we multiply the second equation first. And why would I do this? Well, I do this because I want to make the second equation the same as the first equation. And after the multiplication of the second equation, we'll get negative 6x plus 4y equals to 2, which is basically the same as the first equation, right? So we can do this more different ways. One way you can do the elimination way, which is like this, and we'll get the final answer of 0 plus 0 equals 0. So if we do it this way, we can just assume this as a1 over a2 equals 0, b1 over b2 equals 0, c1 over c2 equals 0. So since all the three values of the ratios are the same, we can also conclude that this system of equations has many solutions. Or we can not do the elimination method, and when we already get this value for these two equations, let's just do it like normal. You plug it into the ratio for the a1 over a2, b1 over b2, c1 over c2, and then we'll get this negative 6 over negative 6 equals to 4 over 4 equals to 2 over 2. And since all these are basically the same, like 1 equals to 1 equals to 1, so this condition is also met for saying that this system of equation has many solutions. But besides that, we can check back at the conditions for many solutions are the lines are coincident and they have the same y-intercept. So when we look back over here, well, the basic formula for a line function, right, is y equals mx plus c, right? That's the basic equation for a line. So we can rewrite this equation into y equals mx plus c basically equals to 4y equals to 6x plus 2, and the plus 2 is of course our y-intercept, right, the c. And since both equations are the same, so the y-intercept for both equations is number 2. Therefore, the one condition is already met. They have the same y-intercept. And then since both lines are the same, and why do I say both lines are the same? Because the equation is the same. So we can say that the lines are coincident and they have the same y-intercept. Therefore, this given system of equations